Okay, so this last section that we will be doing deals with the properties of polygons using coordinate geometry. Now, there are three formulas that we will talk about here. One of them is the Pythagorean Theorem and the distance formula. And also there's another formula that deals with the standard equation of a circle. Okay, so we'll talk about the Pythagorean Theorem and the distance formula. Okay. Now, here our goal here is to derive a formula for the distance AB between 2 points, where A is x1, y1, and B is equal to x2, y2. And the way we do that is use the knowledge of vertical lines, horizontal lines, and the Pythagorean theorem. All right, now I'm going to skip through all of this and just show you how they're deriving this, the distance formula. Okay, so here the distance formula is an equation for expressing the length of a line segment that joins any 2 points, A, which is x1, y1, and B, that's x2, y2. Okay, so if I wanted to find the distance between those 2 points, which is the length AB, here's what they did. They formed a right triangle. Okay, so the distance from point A to some point C, that's the difference between your x coordinates here, x2 minus x1. And then the distance between point C and point B, that's y2 minus y1. And if you recall the Pythagorean theorem, where you got a squared plus b squared is equal to c squared, here they're letting the hypotenuse, which is this longest side, AB, that's the longest side, equal to AC, the square of AC, plus the square of BC, which is this. And then from A to C was x2 minus x1, and that's squared. From C to B, that's y2 minus y1, and that's squared. Okay. Well, anything squared would be a positive, so this would be x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And then since AB is squared, we take the square root of that on both sides. So this is the distance formula from A to B. So the distance AB between points A1, A, x1, y1, and B, which is x2, y2, in the coordinate plane would be AB is equal to the square root of the quantity of x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay, let's see, in this example here we have triangle LRN. We have the vertices where L has the ordered pair 1, -6, R has the ordered pair 5, 2, and N has the ordered pair -3, 4. And we want to identify the angle of triangle LRN with the largest measure and B, the smallest measure. Okay, now they say here that the angle of triangle LRN, that's going to be the largest measure with the being the opposite. The largest measure is going to be opposite the longest side. And the angle of LRN with the smallest measure will be opposite the short side. So here we're going to calculate the distance from L to R using those ordered pairs. All right, so in this case here, L has the ordered pair of 1, -6, and R has the ordered pair of 5, 2. So it'll be x2 minus x1, which is 1 minus 5, and that's going to be squared, plus the square of the differences in your y coordinates, -6 minus 2, and that's going to be squared. Now, 1 minus 5 is -4. If you square the 4, that'll be 16. -6 minus 2 is -8. -8 squared is 64. So 64 plus the 16 would give you this 80. That's underneath the radical. And the square root of 80 to one decimal place would be approximately 8.9 units. And here they did the distance from R to N. R has the ordered pair 5, 2, and N has the ordered pair -3, -3, 4. So here, y2 minus y1, that'd be 5 minus a -3, and that's squared, plus, actually x2 minus x1, then y2 minus y1. Really doesn't matter because of that plus sign. 2 minus 4, and that's squared. Now 5 minus a -3 is 8. 8 squared is 64. 2 minus 4 is -2. -2 squared would be 4. 64 plus 4 would give you the 68. And if you take the square root of 68 to one decimal place, it'd be approximately 8.2 units. Okay, and then finally from L to N, here again, x2 minus x1. That would be 1 minus a -3. And then plus y2 minus y1, -6 minus 4. So here 1 minus a -3 will be 4. 4 plus 4 squared is 16. -6 minus 4 is -10. -10 squared is 100. So 100 plus 16 will give you the 116 that's underneath the radical. And then take this square root, you'll get approximately 10.8 units. Okay. So if we were to compare all three of those distances, then angle R would have to be the largest angle because right here, we got 10.8 units. That's the longest side. So LN is the longest side. So the angle opposite that would be angle R. And you can think of this. We got L and N. The triangle has LRN. So what letter is missing? Has to be R. So that's your angle. And then the smallest was 8.2 units. And that was the length of RN. So that means that angle L would be the smallest angle. Okay. All right, any questions on that? Okay. All right, let me jump to problem number 1. Okay, now I apologize if this is not a best looking picture, but it does say here that ABCD is a parallelogram. And they ask you to find the coordinates of each vertex, A, B, C, and D. in this case here, there's a point down here. Okay, so this is A, this is B, and then C. All right, so in this case here, we need to find the ordered pairs for A, B, C, and then we need to find out what D is going to be. So here's point A. What would be the ordered pair for point A?
Is it -3? I can't really see.
Yeah, -3.
-3,
-4.
-1. Mhm. Sorry about that.
No, it's not you, it's me. Yeah, it's back.
Yeah, it's backwards on here, but when I finish it and post it on YouTube, it'll be.
Yeah, it'll be fine.
Oh, okay.
So here, -3, 1 would be the ordered pair for A. What about for B?
-4.
-4, 4.
Mm-mm.
-5.
-5,
Oh, okay.
4.
Well, I tried.
And what about C? Here's C. What would be the
5.
3 and
4.
a
4.
4? Yeah. So if this is going to be a parallelogram, then D has to be down here somewhere. Let me tell you this, since B and C have the same y coordinates, let me count over from B to C. Okay, this is going to be 1, 2, 3, 4, 5, 6, 7, 8. This distance is 8 units. So from A to some point down here has to be 8 units here. But down here, so this is going to be 1, 2, 3, 4, 5, 6, 7, 8. Here's point D.
5.
It'll be 5 and not -1.
-1.
Okay. So that has to form the parallelogram. All right. Any questions on that particular problem? All right, how about this one? Here we want to find the coordinates of C. And ABC is a right triangle. So here we just need the coordinates of C. So here's C right here. Okay. What would be the coordinates there?
What was the question here?
Oh, they want the coordinates of C, the ordered pair for C.
Oh, 4, 5.
It'd be 4, 5, yeah. Because to get to that point, you have to go to the right 4 and up 5. So the ordered pair 4, 5 would be the coordinates of C. Okay. Questions on that particular problem? Okay, let's say we had something like this one. Here we're gonna find the area of the quadrilateral. Okay, now here the vertex A is negative 2, 2, and B 3, 5, C is 10, 5, and D is 5, 2. So the first thing we need to do is plot the points on the coordinate plane so that we can see what that parallelogram will look like, or quadrilateral will look like. Okay, so for negative 2, 2, we got to go to the left 2 and up 2 and draw the point. So that's point A. And then B is 3, 5, so we go to the right 3 and up 5. And then C, which is 10, 5, we go to the right 10 and up 5. This is B, that's C. And then 5, 2 will be to the right 5 and up 2. So if I connect these points, we do have a quadrilateral. In fact, we have a parallelogram that looks like this. All right, so anytime you're finding the area of a parallelogram, that's this formula, the base times the height. Okay, now the base goes this way. So the distance from A to D, well, if I go from A to D, just count over, this will be 1, 2, 3, 4, 5, 6, 7. So here that base is 7 because the distance from A to D is 7. Okay. I know that's hard to see because I don't have a coordinate grid that has those numbers. All right, the height, if I take point B and draw a height like this to some point here that's on the base, that distance from B to this point on the base here, I can just count down here, count from here to here. This will be 1, 2, 3. That height is 3. So I know what the base is and the height, so I can find the area of this parallelogram. So this will be 7 times 3, which is 21. And this is going to be in square units, by the way. So here the area of that quadrilateral will be 21 square units. any questions about that particular problem there? Okay. Now let's say we have something like this one. Here we got P with the ordered pair, the coordinates 0.5 and 9.25. Q has the ordered pair 3.5 and 8.75, and R has 2.25 and 7.5. Those are the vertices of a right triangle. Which line segment is the hypotenuse? And explain your answer.
Yes.
And let's see. Okay, so let me plot the point. I'm gonna plot the point P, and that's 0.5 and 9.25. Point 0.5 is halfway between 0 and 1. So I'm going to go halfway between there and go up 9 and about 1/4 of the way. So that's going to be way up here. So this is P. And then Q is 3.5 and 9.75. So here's 3 and halfway between 3 and about 4. And up 9.75, that's close to 10. That's about right here. So here's Q. And then R, 2.25 and 7.5. So plot that, this will be about 2 and about 1/4 of the way. You'll have to kind of guess. And then here's 7.5, which is about right here. So if I connect these dots like this, that's kind of hard to see. But with that, sometimes you may have to use the Pythagorean theorem. I mean, not the Pythagorean, the distance formula for each one of these. So I'm going to start with the distance from P to Q. Okay, so I'm using this formula, D is equal to the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Okay. So for PQ, I'm looking at these 2 points here. So this will be x2 minus, well, let's do this. X2 minus x1 going backwards. 3.5 minus 0.5, and that's squared, plus y2 minus y1, 9.75 minus 9.25, and that's squared. So here, 3.5 minus 0.5 would be 3, that's squared, plus 9.75 minus 9.25 would be 0.5, and that's squared. 3 squared is 9. 0.5 squared would be 0.25. At these two, this will be the square root of 9.25. say to two decimal places, is 3.04. That's the distance of PQ. And now for, let's say, QR. So here's Q and here's R. This would be the square root of, let's say, 2.2. Well, if I do 3.5 minus 2.25, and that's squared, plus, I also got to do 9.75 minus 7.5, and that's squared.
So we're doing X1.
What was that?
How we doing it? You doing Q first?
Yeah, Q first and then R. 3.5 minus 2.25, and then 9.75 minus 7.5. Let's see, 3.5 minus 2.25 would be 1.25, and that's squared. 9.75 minus 7.5 would be 2.25, and that's squared. Square 1.25, that would be 1.5625 plus 2.25, and we square that, it would be 5.0625. And this adds up to 6.625. And if I take the square root of that, I'm gonna say 2.57. Okay, so we know QR is not the hypotenuse, because the hypotenuse has to be the longest side. Okay. Now for PR, it's these two right here. I'm gonna do 0.5 minus 2.25. This is all in the square root. And that's squared plus 9.25 minus 7.5. And that's squared. So here, okay, so now 0.5 minus 2.25, negative 1.75, that's squared, and 9.25 minus 7.5. That's 1.75, and that's squared. Square the negative 1.75, you're going to get a positive 3.0625. And they're going to be the same thing for us. Already positive. This will be the square root of 6.125. That would give us approximately 2.47. Okay. So the one that gave us the longest distance was PQ. So here in this case, PQ happens to be the hypotenuse. Any questions on that particular problem? I realized that this was a lot, but you have to find the distance of each one of those using the distance formula and then take the one that has the longest distance.
Yeah, because I would have said QR, judging by the picture.
Mhm. Okay. Okay, let's look at this one and then we'll talk about the standard equation of a circle. All right, the distance between x, 3 and 2, 7 is 5. Here we want to find x. So here, we do need to use the distance formula, but this time we are going to find what x is. We got x, 3 and 2, 7. The distance is 5. We need to know what x is. All right, so in this case here, our distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. All right, so in this case here, the distance was 5, so we put 5 there. And that's equal to the square root of x2 minus x1. This is going to be x minus 2. And that quantity will be squared. Plus y2 minus y1. 3 minus 7. And that's squared. Okay, let's start this problem off by getting rid of this big radical here, the square root. The opposite of the square root would be to take the square on both sides of this equation. And by the way, let's do 3 minus 7, that's -4, and that's squared. Okay, got the square root, we square it, this wipes out, that square wipes out that radical on this side. So all we'll have is x minus 2 quantity squared plus -4 squared. And on the left side, 5 squared will be 25. Okay. Now I can simplify that -4 squared. That's -4 times -4. That would be 16. And now I'm going to get this x minus 2 quantity squared by itself. I'm adding 16, so I need to subtract 16. So 25 minus 16, that's going to be 9. That's equal to x minus 2 quantity squared. So I'm going to move over here, like this over. Now, we need to get rid of the square. The opposite of squaring something would be to take the square root. Now, notice I'm putting the plus or minus symbol because anytime you take the square root on both sides, you have to include that plus or minus symbol. So here, the square root of x minus 2, quantity squared would be x minus 2. And then we got plus or minus the square root of 9. That's 3. Okay. Now, x minus 2 is equaling to plus or minus 3, means I got 2 equations. That means x minus 2 is equal to positive 3, or x minus 2 is equal to negative 3. And then we solve for x for each equation. So for the x minus 2 is equal to 3, that means x is equal to 5. And then for x minus 2 is equal to negative 3, if I add 2, you get x is equal to negative 1.
Goodness gracious.
Yeah, yes.
Where did the 3 come from?
Square root of 9. What number times itself gives you 9? Any other questions? Okay. So in this case here, we got 2 possible x values. That would give us a distance of 5. All right, questions on that?
Is that it? Or is it plug in the trial?
I think, I mean, you could, because if this was 5,
Right.
5 minus 2 would be 3, 3 squared would be 9, 3 minus 7 is negative 4, negative 4 squared is positive 16, 16 and 9 is 25, the square root of 5 would give you 5. And then for negative 1 minus 2 is negative 3, negative 3 squared is 9, and that's 16 plus the 9 would be the same thing. So it's both.
So, with that 9 and x minus 2 squared. Yeah, you only do that when you're trying to get the square root of 5.
Yeah, when you're trying to get rid of that square.
To get rid of the square.
Yeah. Mhm. Okay, any other questions? Okay, let's quickly talk about the distance formula and the standard form equation of a circle. Okay, and basically that's derived from the distance formula as well, because you're finding the distance from the center of the circle, which is your A in this case, to some point on the line. That distance is called the radius. So I'm just going to go straight to it. That's the standard equation of a circle with the center, h comma k. The radius is r, and it's this, x minus some h quantity squared plus y minus some k quantity squared, equaling to r squared. All right, let's look at this particular problem here. Let's say I want to write the standard form of the equation of the circle that's given here. Okay. Now we're given the center, which is 4, 3, as you can see here. A is 4, 3, that's the center. And B is a point on the circle. negative 1, 5. Now, what I need to do here is find the distance between those 2 points, A and B. That's going to give me the radius of this circle. Okay. All right, here we go. I'm going to say R is the radius. That would be the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared.
You're pulling out from the distance formula, not
Yes.
from this right here.
Not from the standard form.
Okay.
Right. Because I'm going to use standard form, but I need to know what the radius is
Oh,
first.
Okay, okay.
That's the first thing I need to know there. Okay, so now, to find the radius, x2 minus x1, this will be 4 minus negative 1. And that's squared. Plus y2 minus y1, 3 minus 5. And that's squared. Get 3 minus 5. All right, and then next, simplify. 4 minus a negative 1 would be 5. And that's squared. 3 minus negative 5, that's negative. 3 minus 5, that's negative 2. And that's going to be squared. Five squared, or 5 times 5, that's 25. And then negative 2 squared, or negative 2 times negative 2, that's 4. 25 plus 4, that gives me 29. And I will leave it as the square root of 29. Okay, that's the radius of that circle, the distance between A and B. Now that 4, 3, that was in the middle of that circle, that's the center. And I have my radius of the square root of 29. So here, this is going to be your H and that's going to be K. The center is always going to be the ordered pair H and K. Because in the standard equation for a circle, you need X and Y in it. And that standard equation, of course, is X minus H, quantity squared, plus Y minus K, quantity squared. That's equal to R squared. Now we substitute H, K, and R in the standard equation. So I'm going to bring down the X minus, the H is the X coordinate of the center, that's 4, and that's squared, plus Y minus K, that's the Y coordinate of that center, that's 3. And that's equal to the radius, which is your R, that's 29, and that has to be squared. I've got the square here. Okay. Now, this will be X minus 4 quantity squared plus Y minus 3 quantity squared. That's equal to, if I have the square root of 29 and I turn around and square, it's going to be what's underneath that radical. That'd be 29. So this is the standard equation of a circle, of this circle, with the center at 4, 3, and the radius at the square root of 29.
So that is the solution to problem 5.
Yes. Any questions about the standard equation for a circle? Okay. Okay, let's talk about the midpoint formula. I'm just going to go right straight into it. Okay, the midpoint is always going to be the point that's in between, exactly in the middle of the other 2 points. Okay. And what that means is when you have the midpoint, that means the distance from, let's say, A to the midpoint M is the same distance as it is from B to M. Okay. Midpoint means in the middle of your 2 points. And if you were given 2 points A and B, and you want to find the midpoint, here's how you'll find it. And they labeled the midpoint as M, which is going to be X sub M, Y sub M, of a line segment joining A and B, where A is X1, Y1, and B is X2, Y2. That means the X coordinate, which is X sub M, would be this. X1 plus X2, that sum is divided by 2. And the Y coordinate, YM, is equal to Y1 plus Y2 divided by 2. So for your X coordinate, for the midpoint of your, for the X coordinate of your midpoint, you add the 2 X coordinates together, divided by 2. And for the midpoint of the Y coordinate, you add the 2 points together and divide by 2. So here I'm just going to jump over to problem number 30 on page 796. All right, in this case here, I want to determine the midpoint of the line segment with the endpoints A and B. So in part A, we got this. 4, -2, A, and point B, 7, -6. So for the X coordinate of the midpoint, we do X1 plus X2, that's divided by 2. So here, X1 would be 4, and here's X2, that's 7. So 4 plus 7 would be 11, and we'll leave that as 11 halves. Okay. And then the Y coordinate of your midpoint, that's Y1 plus Y2 divided by 2. So Y1, that's -2, plus Y2, that's -6. That sum would be divided by 2. So -2 plus -6 is -8. That'd be -4. Okay. So our midpoint, I'm gonna label that as M. That's the ordered pair, 11 halves, -4. Okay, questions on part A? Okay, part B. Point A has the order pair -6,2. Point B has the order pair 4,3. And I want to find the midpoint of line segment AB. So here, to find the x-coordinate of the midpoint, that's x1 and x2, I add those two together. -6 plus 4. Divide that by 2. Let's see, -6 plus 4 is -2. Divide that by -2, you'll get -1. So the x-coordinate of the midpoint is -1. And then for the y-coordinate of the midpoint, 2 plus 3. The sum of the two y-coordinates divided by 2. So 2 plus 3 is 5, and I'll leave that as 5/2. So that means our midpoint will be the ordered pair, -1, 5/2. Okay, questions on that particular problem? Just finding the midpoint of those two segments, of those 2 points. Okay, here's the last problem that we'll do here. We'll end it with this. Find the equation of a line that is the perpendicular bisector of AB, with the endpoints 7, 3 for A, and B is 4, -1. Okay. Now, of course, a perpendicular bisector looks like this. Let's say we have a line segment. And this perpendicular bisector goes through the center or through the midpoint of this line and is perpendicular to it. So this green line, that's the perpendicular bisector. Because that perpendicular bisector goes to the center and it's going to be perpendicular to the other line. Okay. Now we got endpoints where A is 7, 3. And B is 4, -1. So the first thing we do here is find the midpoint. Okay, that's the point in the middle of A and B. So our x-coordinate of the midpoint, we do 7 plus 4 divided by 2. So 7 plus 4 is 11. And if we divide that by 2, we'll leave it as 11/2. And then y sub m, that's the y-coordinate of the midpoint, y2 plus y1 plus y2. 3 plus -1, that's divided by 2. So 3 plus -1 would be 2. 2 divided by 2 would be 1. So our midpoint is 11/2 and 1. That's the midpoint. 11/2 and 1. Now, if we're going to find the equation of the line, we also need to find out what the slope is. Okay. So here's how we find the slope. y2 minus y1 divided by x2 minus x1. That's how we find the slope of the line. Let's see here. y2 minus y1, that's going to be -1 minus 3. Divided by x2 minus x1, 4 minus 7. So if I do -1 minus 3, that's -4. And then 4 minus 7, that's -3. This would just be a positive 4/3. Since negative divided by negative is a positive. Okay. So here we're finding the perpendicular bisector. That means we're finding the equation of the line that's perpendicular to this given line. So we need to use that perpendicular slope by doing the negative reciprocal of 4/3, which is -3/4. So the perpendicular slope there is -3/4. And finally, we do the y equal mx plus b because we need to use that perpendicular slope of -3/4. And not only that, we need to use that midpoint. We also need to use the midpoint of 11/2 and 1 in this equation that's in slope intercept form, y equal mx plus b. Yeah, I know.
Are you using a positive or negative 3/4? I can't.
A negative.
Negative.
3/4.
It's perpendicular. You have to do the negative reciprocal. Okay, let's substitute here. This y is 1 equal to the slope -3/4 times x, which is 11/2 plus b. Now there's nothing I can divide, no common factors I can divide out. So I have to multiply numerator times numerator and denominator times denominator. I have to do -3 times 11. That's -33 over 4 times 2, which is 8, plus b. Okay. So here, I need to add 33/8 on both sides to get b by itself. So let's see, 1 plus 33 divided by 8. Then if I use the math key and change that to a fraction, this would be 41/8. So your y-intercept, which should be, that's 41/8. And our slope was -3/4. So the equation of the line going through, that is the perpendicular bisector of AB, is going to be y is equal to -3/4 x plus 41/8.
In real world stuff, is it like just engineers, people like that, is you just kind of imagine.
Yeah.
Wow.
Who in line ever? I mean, I can't think of anybody else besides like engineers, architects that would use this kind of thing.
Yeah.
Yeah, I know. So that's pretty much wraps up section 13. That's going to wrap up this course here. Okay, so of course you got the homework for 13.1 and 13.2. They should be already open. Also, the other class assignment is up there as well. That's due, all that's due May 1st, Saturday evening. I think I got the review for the final exam open. It's probably going to be open tomorrow. So you'll have enough time to get enough practice as you need to prepare for the final exam, which is in WebAssign. It will open Sunday. The final exam will open Sunday. The due date for that will be on Wednesday. Okay.
The class assignment's not on Blackboard, it's
On WebAssign. Yeah.
And we just keep learning. Well, it's on work.
Okay. All right, any other questions?
Well, I definitely email you.
Okay.
Sorry, but
Okay. Let me say that I pretty much enjoyed everyone in here. I enjoyed one of you in this
Oh,
class,
okay.
toward this
I'm
class.
so glad I got a chance
Yes,
to have you. Thanks for that.
Mhm.
Can I, discuss something with you after class?
Yeah,
All right.
all right.
yeah.